Question number 21. There are no choices. Question number 22. There are no choices. And question number 23. There are two choices, but there are no givens. So how can I solve them? We will not solve these questions. Question number 24. What is the total force? So he simply wanted to know the total force. We all know this rule. P, which is pressure, is equal to F, which is force over A. So simply the force is equal to the pressure times the area. So if we wanted to know the force, we wanted to know two things: the pressure and the area. Calculating the area is very simple. First, we have to calculate the pressure. The total pressure is equal to the atmospheric pressure atmospheric P plus the pressure on the water, the P on the water. The total pressure or the atmospheric pressure is equal to, he gave us in the givens, is equal to 1 times 10 power 5. This is the atmospheric pressure. The pressure on the water is simply equal to the basic rule which we all know, P, which is density. Let me write density instead of P. It's rho, not P. Density times H times the gravitational acceleration. If you wanted to know how did this rule come, you have to watch the videos in the description box. I highly recommend you to see these videos. Let us substituting in this rule 1 times 10 power 5 plus the density of water is 1000 kilogram per meter square times the height, which is 1 meter. He gave us the deep, which is simply the height, times the gravity, which we all know, 9.8. This is equal to this number, Newton per meter square. This is the total pressure. The area, or let me write the radius first. The radius is equal to the diameter over 2. He gave us in the givens the diameter, so the radius is 2 over 2. Is simply 1 meter. So the area of the surface, he gave us the radius, so the surface is simply a circle. So the area, or A, is equal to pi, which is 3.14 times r power 2, or r squared. 3.14 times 1 power 2, simply 3.14 meter square. Okay, so here we have the area and the pressure, so we can simply calculate the force. F is equal to the pressure, which is this number, times the area, 3.14, which is simply equal to this number, 3, 4, 5, which is approximately is equal to 3.4 times 10 power 5. Newton. So the answer is A. Question number 25. In a large tank of liquid, the hydrostatic pressure at a given depth is a function of. There's a rule. Or let me see the hydrostatic pressure is the pressure present within a fluid when it is at rest. So this is the definition of hydrostatic pressure. We know this rule. The pressure is equal to the height times the density times the gravitational acceleration. If you don't know this rule, I highly recommend you to see my videos or the videos in the description box. So the pressure is associated with the height and the density. So the answer is D. Is A and C A and C are correct. So the answer is D. Why we can't choose B? Because he didn't say in the question there is a force applied. So we can't choose the surface area. Question number 26. This question is associated with Pascal principle. If you know Pascal principle, you can solve this question easily. If you don't know it, I highly recommend you to see the videos in the description box. One of the results or the conclusions from Archimedes principle is F1 over F2 is equal to A1 over A2. F is the force and A is the area. We can substituting in this rule and simply find F2. F1 is 1500 over F2, we wanted to know it, is equal to A1, 0. We have to calculate A1 and A2, sorry. A1 is equal to by 3.14 R power 2. The R1 is 0.2, so 3, let us substituting in this rule, 3.4 times 0.2 power 2, which simply is equal to 0.1256 meter square. This is area 1. A2, the same rule, 3.14 times R square. R square, he said in the question, is 0.04. So let us substituting 3.4 times 0.04 power 2, which is equal to 5.024 times 10 power negative 3. This is A2. Let us substitute in the first rule, F1. Let's make a substitute directly. If F1 is, he said in the question, 15,000 over F2, we want to know it, is equal to A1 over A2, 0.1256 over 5.024 times 10 power negative 3. So F2 is basically is equal to the 600 Newton. So the answer is A. By what factor is the total, question number 37, by what factor is the total pressure greater at depth of 850 meter in water than at the surface area pressure? Don't be confused from the way he tells you the question. He simply wants to know the ratio between the pressure in the water and the pressure at the surface, or the atmospheric pressure. Okay, let us calculate the total pressure on the water. Is basically equal to the atmospheric pressure plus the pressure in the water. The atmospheric pressure we all know 1 times 10 power 5 plus the pressure on the water, which is basically equal to, let us substitute in this rule, 1 times 10 power 5 plus h times the density times the gravitation, the gravity, which is 9.8. One times 10 power 5 plus, he says the question, the height is 850 times the density of water. We all know the density of water is 1000 times the gravity, which is 9.8. All of this is equal to this number, Newton per meter square. This is the total pressure. And we all know the pressure or the atmospheric pressure. The atmospheric is equal to 1 times 10 1 times 10 1.01. Let us use the way he gives us in the question. 10 power 5 Newton per meter square. And let's divide it by the total pressure by the atmospheric pressure. So the ratio is equal to 1.01 times 10 power 5, which is simply equal to 83.4, which is approximately is equal to 83. So the answer is B. Okay, a very easy question. We all know this rule. The pressure, is equal to density times height times the gravity. Let us substituting this rule. The density he give us in the questions 13.16 times the height, which is, he give us in the question the height in centimeters, so the height is equal to 72.6, which is equal, let me write centimeter, which is equal to 7.26 meter. So this is the height in meter. We have to write it or substitute it by meter in the times 7.26 meter times the gravity, which is 9.8. So the result will be 0.968 times 10 power 5 Newton per meter square. Okay. Question number 29. Very easy question. It's very big question, but the only givens he gave us that I highlight it. The dam 2 is twice as height and twice as wide as dam 1, and he wanted to know the how much greater force of the water. So he simply wants us to know the ratio between the force of the dam 1 and the force of the on dam 2. Sorry. I'm really sorry. Sorry. My laptop is really good. Oh, here we go. The difference, I just said it. So we wanted to calculate the ratio between the forces. So simply we wanted to know the pressure and the area. As we all know this rule, I read it a lot of times. Pressure is equal to F over A. So if we wanted to calculate F is basically P times the area. Okay. First we have to calculate the area, so we have to calculate the height and the width. H2 is equal to 2H1 height. Let me write it like this. Height of dam 2 is equal to 2 times height of dam 1. Height of dam 1. And the width of dam 2 is equal to 2 times the width of dam 1. So area 1 or A1 is simply equal to H1 width 1, and A2 is simply equal H2 times width 2, which is basically equal to 2 times H1 times 2 width 1, which is equal to 4H1 times width 1. So it's simply equal for A1. Okay, let us calculate the pressure. P1, or the pressure on the first dam, is equal to H1 times the density times G, or the gravity. This is P1. P2 is simply equal to H2 times density times G. So it's simply equal to H2. I just said H2 is equal to 2H1. So 2H1 times density times G is basically equal 2p1 2p1 2 times p1 to be more clear 2p1. So f1 is a1 times p1. A1 we just traded a1 p1, and f2 is equal to a2 times p2, and a2 is equal to 4a1 4 times a1, and p2 is 2 times p1 2 times p1. So 2 times 4 is 8 8a1 p1. So the ratio between f2 and f1 is 8. This is very easy rule, very easy question, sorry. We will use this rule. The pressure is equal to the density times the height times the gravity. We will substitute in this rule. He gave us the pressure, the atmospheric pressure, we all know this, 10 power 5 is equal to the density. The density of air is 1.29 times the height times the gravity, which is 9.8. We wanted to know the height, so simply h is equal to 10 power 5 over 9.8 times 1.29, which is equal to 7,910 910, which is approximately is equal to this number here. Sorry, this is approximately is equal to this number. So the answer is A. Yes, this question. Question number 31. He wants us to calculate the hydrostatic force. When we want to calculate any force, we have to know the pressure and the area. When we want to calculate the hydrostatic force, we will use half of the height when we calculate the pressure. Or let me make a definition for it. It's not the half of the height, is the distance between the center of mass to the surface. The center of mass to the surface. So let us say the half of the height, okay? Hydrostatic force. Hydrostatic force is equal to the pressure times the area. I had just said when we want to calculate the hydrostatic force, we use half of the height when we calculate the pressure. So the height, the pressure is h dot. It's h dash. I don't know how to write it in the keyboard, but it is h dash, or let me say h over 2. H over 2 times the gravity times the density, and the area is simply, let us substituting on the area. Area is the height times the width, height times the width. By substituting, h over 2 is basically 75. H over 2 is basically 75 times the gravity, which is 9.8, times the density give us in the question. He didn't give us the question, but we all know the density of water is 1000 kilogram per meter cuboid, times the height, which we will substitute on the pressure by the half of the height. But when we calculate the area, we will not substitute it by half of it. We will the whole height. We will substitute it when we calculate the area. Okay. So the height is 150 times the width, which is 1200. All of this by using the calculator is equal to 13.2 times 10 power 10 Newton. This is the hydrostatic force. The last question in this video. Okay. How deep under the surface of a lake would the pressure be double that at the surface? First we have to calculate the total pressure. The total pressure, or the absolute pressure, the total pressure is equal to the atmospheric pressure plus the pressure on the water. It's a lake, so it's water. We all know the atmospheric pressure, and he gave us in the question. Thanks for him. 1.01 times 10 power 5. This is 10 power 5 plus the pressure in the water is simply, we will use this rule, H times the density times the gravity. Is equal to 1.01 times 10 power 5 plus density of water, we all know this, 1000 times 9.8 times the height. How deep under the surface of a lake would the pressure be double that at the surface? So he wants to know what is the height that make the total pressure is equal to the double of the atmospheric pressure. So the all things that we have to do is make an equation 1.01 times 10 power 5 plus 1000 times 9.8 times the height is equal to the double of the atmospheric pressure. So 2 times 10 1.01 times 10 power 5 after make this equation and solve it by the calculator or manually, you will find the height is equal to 10 power 3 meter. So the answer is C.